Hello everyone, inside this video we're going to be tackling another projectile motion problem, and inside this problem Bobby J is visiting Dean's Blue Hole in Long Island. And for those of you who are not informed, Dean's Blue Hole is the second deepest blue hole in the world, and it falls right behind the Dragon's Hole in the South China Sea, if I'm not mistaken. And this hole is actually about 622 feet, 632, but I know it's approximately 202 meters, which is ridiculously deep. And it's actually a really, really beautiful sight. So if you're ever in the Bahamas, it's one of those attractions that I would highly recommend. I've been there myself, and it is breathtaking. But let's begin. At Dean's Blue Hole in Long Island, Bobby J climbs atop a 28-meter cliff to make a grand appearance. He wants to push off horizontally with such a speed from the rocky platform to clear the relatively shallow waters that extend 5 meters, measured directly below his launch point. What minimum speed is needed for Bobby J to clear the shallow waters and land into the blue hole? So here I have a sketch of what is happening, and now I'm going to draw a more detailed diagram. So here I have some initial displacement, and this is my object here, and in this case my y will be 28. Actually, my y naught will be 28, and I will take the ground as 0 again. And what's going to happen is, since I'm pushing off horizontally, I'm going to follow a path like that, and I know that the shallow waters extend 5 meters horizontally. So I have some V naught here, and I want to know what V naught do I need such that my maximum horizontal distance is 5 meters, because we're assuming that he hits the waters 5 meters out, or 5 meters or more. But in this case, I only need to know the minimum, which is at 5 meters. So what horizontal velocity do I need to clear these shallow waters? And in this case, I know maximum horizontal distance, which is 5 meters, and what I want to find is V naught. And V naught in this case will be equal to the velocity in the x, because my angle is horizontal. And if I were to take V naught x, which is V naught cosine theta, I would get V naught cosine of 0, which is 1. So V naught is equal to V naught x. So what's happening here? I'm 28 meters up, and I want to jump with a horizontal velocity such that my maximum horizontal distance is at least 5 meters. Okay? So immediately I know that this is what's happening. Immediately I know this is what I'm dealing with. Okay? I know that the maximum horizontal distance is equal to the velocity in the x multiplied by the time. Okay? And I also know that the maximum horizontal distance occurs at the time of flight. So the total time of flight will give me the maximum horizontal distance. So I know what my maximum horizontal distance is, and this is what I want to find. So it's a bit of algebra. Now, how do I find the total time of flight? Well, I can look to what's happening in the y. If I were to use this equation, I know that my change in displacement, my y minus y naught, Vy t minus 1/2 gt squared What I do know is that my final height is 0. And I also know that my initial velocity in the y is 0 because I push off horizontally. So I push off with no velocity in the y initially. So that's 0. And I'm left with minus 1/2 gt squared. And these negatives, they cancel out. And how high am I falling from? I'm falling from 28 meters. So solving this, 2y0 is equal to gt squared. So t is equal to the square root of 2y0 divided by g. And all of these are things that I know. 2 times 28 divided by 9.81. And this gives me 2.67 seconds. 2.67 seconds is my total time of flight. Now that I have my total time of flight, I can calculate my maximum horizontal distance. This is key. We're assuming that the maximum horizontal distance occurs at the total time of flight. And that's very important. And we're assuming that 5 meters is our maximum horizontal distance because after 5 meters, I would like to hit the water. It doesn't have to be at 5 meters. It could be at 5 meters and some change. It could be 6 meters. But in this question, I only want to know the minimum velocity to get me to 5 meters. So moving over here. So my distance is 5 meters divided by 2.67 seconds, and this is actually going to give me a velocity of 1.87 meters per second. But remember, velocity, initial velocity in the x is equal to v0. Remember that I'll do it right here. Is equal to v0 cosine theta, but theta is 0 because I'm pushing off horizontally. And cosine of 0 is 1. So my horizontal velocity that I want to push off with to get me past those shallow waters is exactly 1.87 meters per second. And thank you so much for watching, and congratulate yourselves, because again, physics is a challenging subject, more challenging for some than others, but you being here shows that you have grit, and I applaud that, and I want to encourage you to continue through the gauntlet. I promise you that you may not fall in love with the physics, but you'll respect it, and I'm going to try my best to help you understand it. So until next time, have a wonderful evening.